So this is an exponential equation. I cannot apply log to it. You can say apply natural log to both sides. I can't. First of all, I cannot apply log to a difference. And I cannot apply log to 0. So looking back to all this list, I realized that there is some connection to this. Of course, not linear. Of course, not rational. We'll talk about that. Not polynomial, not radical, not absolute value. It's an exponential equation, but it's also quadratic in form. So I will use a substitution. Why? Because I realize that I can denote this by t only if this can be denoted by, otherwise the method doesn't work. By what?
T
squared. E to the x. If I square e to the x, I copy the base, multiply the exponents. And that's how I get the t squared. Knowing that, then I have t squared minus 2t minus 3 equals 0. We know how to factor this into t minus 3 and t plus 1. So we do have two solutions in t. But that's not enough. Actually, I should have written this. We let e to the x to be t. Or if you want t equals e to the x, same thing. So then this is a new equation and this is a new equation. What is this? What new equation is this? E to x equals 3. And e to x equals negative 1. But this is not possible. How come? Remember the graph of e to the x? It's what we are facing these days. This is e to the x. This is this side. And the other side is this. They can never meet. E to the x can never be a negative number. They will never intersect. So this equation has no solutions. But the first one does. How do I find x in this equation? What should I do to both sides? Anyone? We apply natural log x. We know that natural log e is 1, so the answer is natural log 3. And this is the only answer. There are no solutions coming from here. Is anyone listening? Is anyone with me? Anyone?
listening.
Okay, thank you, thank you, thank you. Okay, log equations. Remember, log function is what I like to call not friendly. It's like square root. It's like rational. What do I mean by that? Restrictions. This is not a friendly function. It's not defined everywhere like polynomial functions. Polynomial functions never give us a headache. Why? They're defined everywhere. I don't have to worry about domain. But here I have to worry about domain. Let me refresh your memory on, I just put this in the recycle, but let me refresh your memory on this because I didn't say it. Any log equation can be converted into an exponential one. From the base, we start from the base always, and we go counterclockwise. A raised to y equals x. Okay. So our first problem, let's move on to page 515. I'll choose, you choose anywhere you want from 49 till 92. Allow me to start first. Let me put this away because I spilled before water. I would like to start with 59. And 59 is log base 4 of 3x plus 2 equals 3. Obviously, this is a log equation. There are two methods. You have to use one or the other. It's up to you. I'll tell you the one I like, and you can choose the other one if you don't like mine. By two methods, I mean I either state domain, like we did with rational equations, and then go back and check, I'll explain, or you say, I don't want to state domain. I don't want that, but I promise to check all prospect solutions back in the original problem. Original equation. I am lazy when it comes to this. I prefer that. But it's up to you. You can say, no, I don't want to state a domain, but I promise to always check solutions. And that's fine. No problem. But I'm going to use this one. It's easier for me, but it may not be easier for you. You may say, I prefer that. That's fine. I look at this equation. I see a log. I see the log is applied to 3x plus 2. I immediately write that 3x plus 2 has to be greater than 0. Otherwise, the function doesn't exist. It's undefined. I move 2 and divide by 3. So this has to be whatever solution I get has to be a number greater than negative 2/3. If the number is not greater than negative 2/3, I will say this equation has no solutions. And I don't have to go back and plug it in and la, 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 la. I only have to check that it's greater than negative 2/3. So I stated the domain, and I will only look here. So now I'm going to copy the equation. And I know that this can be converted into an exponential equation. How do I convert this into an exponential equation? I start with 4 raised to
3
equals exactly 4 to the third equals 3x plus 2. Now this is linear. 4 to the third is 64. And this is 3x plus 2. I have to subtract 2. I get 62 equals 3x. So x equals 62 over 3. Is this a number greater than negative 2/3? Yes. I wrote 64. I'm sorry, I just realized. So 16 times 4. Right? Am I correct? I'm correct, I think. Right? 4 squared, and yeah, I'm correct. For a second, I said, oh, maybe I rushed. Any questions? Any questions on this? Okay, moving on. Please choose, or I will. 1, 2, 3. 68. 68 log base 6 of x plus 5 plus log base 6 of x equals 2. Anyone, any questions, please? Anything? Okay, so in this particular case, I see 2 logs. Well, since I'm going to stick with my method, I'm going to write that x plus 5 has to be positive, because otherwise this log doesn't exist. And then x has to be positive. Now I have 2 conditions. And I have to find their common domain. So this one is greater than negative 5, and this one is greater than 0. If you need to see this, that's fine. Let's graph them. greater than -5. I don't care for units. And the other one is greater than 0. I need both colors, of course. The common domain is 0 to infinity. Whatever this equation comes out to have as an answer, if it's not a number between 0 and infinity, I'll say sorry. It's not acceptable. Okay. So at this point, I remember that there is a property of log that says that if you have a sum of two logs in the same base, you can condense that as log base 6 of what? Can anyone tell us what to write? It's the product rule. So this will be x multiplied by x plus 5. If you want to put it in brackets, that's fine. So log base 6 of the product is log base 6 of x plus log base 6 of x plus 5. At this point, I convert, only now I can convert into an exponential equation. How do I convert this into an exponential equation? What do I write?
6 raised to the second power equals x times x plus 5.
And because I want to cut back on writing, I'm just going to multiply already. Excellent. 6 squared is 36. Then x squared plus 5x. I move 36. It doesn't matter which side. It's quadratic. I have to write x squared plus 5x minus 36 equals 0. I see a 9 and 4. Right? So x squared, and then plus 9x minus 4x, and I get two solutions. X equals -9 and x equals 4 with a big question mark. Why? Why there is a question?
X equals -9 can't be a solution because we already said that x has to be between 0 and positive infinity.
Excellent. Again, if you don't state the domain, if you don't do this, then you get -9 and 4, and you have to go back and plug them in. When you plug in -9 in here, you know it's not going to work, so you can disregard it. That's the method of solving log equations. Anything else you would like to pick? Anything?
Can we do 65?
Yes, of course, 65 it is. 60, where are you, 65? Yes, the 6 plus 2 natural log equals 5.
Yes.
Keep an eye on what I copy. Oh, no, 65 is something else. I already looked at something else. I looked at 63. So you want this one, right?
Yes.
Perfect. Great job. Okay, now I see a combo. I see a square root and natural log applied to it. No matter what, I have to write x plus 3 greater than 0. I cannot write equal. If I did not have natural log here, I would have written equal as well, because the square root allows 0. But because I have natural log, I cannot put the equal symbol here, and this is x greater than -3. Now, I can write the equivalent equation. So keeping in mind that if I don't get a solution that is a number greater than -3, not -3, then I'll say, sorry, no solutions. So I know the base of this. In case you ever forget, they are paired together. The natural log with its inverse function. So we do not write this base, but we know it's there. So e to the first power equals the square root of x plus 3. Aha. And now I'm back. Look. That log equation changed into a radical equation. So what do I do? How do I solve this? How do we solve radical equation? And the power is?
Square.
Very good, awesome. So then e squared equals x plus 3. So x equals e squared minus 3. This is definitely a positive number. It's 2.78 squared minus 3. You can, here's your e. The plain e is the division symbol with a second key. If it's plain, one possibility. The second possibility is with the second key with natural log that pops up with the power already, so you can put 2 and then minus 3. Guaranteed to be a number greater than -3. So this is acceptable, and this is the correct solution, and it's greater than -3. Good pick. Anything else you would like to pick?